Welcome back, Burn 58B. I'm going to talk about the difference between narrow and wide parabolas and how you can tell the difference before you even start to graph them. So again, this is 58B. So a narrow parabola, as you can see, all of these parabolas have the same vertex, right? So what makes one narrow versus one wide? And the answer to that is going to be the coefficient. So when the absolute value of the coefficient of the perfect square here is greater than 1, then your parabola is going to be narrow. So this is a narrow when it's greater than 1. Now that's the absolute value. A great way to think of this is that the negative sign only tells you which direction it's facing and that it's facing down. The positive tells you that it's facing up. It's the number itself that tells you whether or not it's wide or narrow. So this is bigger than 1, so it's going to be narrow. And this is a 1, so it's your standard 1-to-1 parabola. It's not, it's a standard size. But when you have less than 1, in the case of a fraction or a decimal, then your parabola widens and it gets bigger. And I think that's due in part to, if you look here, you've got a 3 and you've got a slope of 3 here, 1 to 3 in your vertical space, right? This is your x. This is where your x travels on the y. It goes up or down 3, however you want to, it goes down 3, right? And your here you have 1/3 from your vertex. You're 1/3 of a slope from your vertex here. So if you look at it like that, then it makes perfect sense as to why this would be more narrow and this one would be more wide. So let's try a couple practice problems just to kind of wrap our heads around what that looks like. So here is our parabola. We're going to complete the square and graph this parabola. We know it's a parabola because we have a y term and we have an x squared term and another x term and then a whole number. That's how we know it's a parabola, is because it has those elements. So the first thing we have to do is solve for y. So here we've solved for y. We started by getting y alone, the y term here, and it has a lead coefficient of 3. So whenever your y term has a coefficient, that should be an indicator that you are going to have a wide parabola, because you're going to have to divide everything over here and you're going to get a fraction for x, unless this is a multiple of that. So look at that relationship. That's going to tell you right away whether you're going to get a narrow or a wide parabola. You can always almost start to visualize what it's going to look like. So now we know we need to factor and get that perfect square. So let's do that next. So here's our step 2. We have factored out 1/3 from the x squared and the x term, and we've put that in our parentheses here, getting ready to complete the square. So let's go ahead and complete the square. All right, so we have completed the square, and we have that y is equal to 1/3 x minus 1 squared minus 2. Now, keep in mind, here we were completing the square. This is where we got ready to do that. We divided this -2 by 2. We got -1, right? So when we squared -1, we got a +1. Keep in mind, whenever you have a coefficient here, a factor times all of this, whenever you're ready to subtract that from the same side, you have to account for this coefficient by multiplying it times the coefficient when you put on the outside of the parentheses. So we took that +1 And we were going to put a -1 on the outside of the parenthesis, but it has to be multiplied by this 1/3. So we subtracted -1/3 because -1 times 1/3 is -1/3. So when we combine those, we got -6/3, which is a -2. That's how we got that. So from here, we're able to find our axis of symmetry, which is the opposite of this number. So that's a +1. So we are going to, I'm going to use this orange and do in our axis of symmetry, which is right here. Just write down this 1. Okay, and now I'm going to do it in purple for the rest. The vertex is going to be 1, -2. That's not 1, -2 at all. So 1, -2 is here. I put it in the wrong spot, sorry. Now we have 1, -2. And I think that I might actually draw over the top of that because, does this open down? No, it's positive, so it opens up. So that's okay. 1, -2. That is going to be your vertex. My intercept is 0. My y-intercept is 0, -5/3. So that's 1 2/3. So right about here. That's going to be that. And then this is going to be on the opposite side right here, my mirrored point. And what you're going to want to do is pick a point and sub in for x in order to find what you need to do, right? So I'm going to choose, let's choose 4. And I'm going to solve for 4. I'm just going to scooch this up a little bit, and I'm going to pick this point 4. So if x is 4, right? So my x would be 4. So let's sub that in and find our point. Y is equal to 1/3 4 minus 1 squared minus 2. 4 minus 1 squared is 3. 3 squared is 9. 9 divided by 3 is going to be 3. So y is equal to 3 minus 2, which is going to be 1. So 4 and 1 is going to be another point. So I just need to go to 1, 2, 3, 4, and 1. And now I can find that mirrored point on the other side. 1, 2, 3, 1, 2, 3. So now I can see where my parabola lives. And it's a wide parabola. And fortunately, I like this program. It allows me to adjust it and get it on the points once I have drawn it. This is Good Notes in case you ever want a really good software for the sake of math notes. This does allow you to do some really good adjustment. And obviously, I did not put this point in the right spot because I have everything else lined up where it's supposed to be. And this one is way off. It's a little bit higher. It's supposed to be right here. Let me see if I can get that right back there on that line. Yeah, so I should have made this point more right here. It's just, me not being a very good artist or mathematician at that point. I thought I was pretty level, but apparently not. All right, so you can see how that parabola is really, really wide. And you can see how to find a point. If you don't want to try to use your vertex and your y-intercept, especially if you have a weird, funky fraction like that, then just pick a point for x, sub it in, and then solve for the y value, and then get your mirrored point to help you draw your parabola. So there you see 58.3. And you can see how that works for a wide parabola. Let's do a narrow parabola now. All right, so here is our parabola. We know it's a parabola because we have one y term and an x squared and an x term and a whole number. So we're going to solve for y. So that wasn't super difficult. We just shifted everything over and subtracted it from both sides, except for the y. So y is equal to -2x squared minus 12x minus 17. So this tells me right away that our parabola is going to open downward. And let's do step 2, which is to set it up for the completing the square. All right. So that didn't take long at all. All I did was I took my first 2 terms here and I factored out a -2. So I divided everything by -2. So that left me -2 times x squared plus 6x, and then I left a little room for my third term, and I shoved this -17 to the outside of the parenthesis, which is kind of handy because I couldn't divide him by 2 anyway. I would have had a fraction. And if he's inside the parenthesis, then this coefficient has to be applied to him. But if he's outside, we don't have to divide him. All right, he's already multiplied by -2. He's fine. He is in his original state. So now we're going to complete the square. All right, so now that I've completed this square, let's go through those steps. Step 3, completing the square. We divided 6 by 2. We got a +3. We squared the +3. We got a +9. So if we added 9 to this side, we had to subtract it from out here. But before we subtracted it, we have to apply this -2. So -9 times -2 is a +18. So that is what you have to do. Whenever you come out here and you add this 9, you have got to then subtract the coefficient times that -9. Or actually, it's going to be, you're going to do whatever it says to do. You're going to add whatever that is, right? -2 and -9 together. Now, if this is a +9, then we know this would normally be a -9. But we have to apply the coefficient here, which would give us a +18. So that's 18 right there. So -17 plus 18 gives us a +1. So now that we have it completely factored and completed the square, we know that our axis of symmetry is going to be -3. So 1, 2, 3. We know it's going to open downward because we have a negative coefficient here. And our vertex is going to be -3 and 1. So +1 right there. So now we just need to find that other point. So step 4 is other point. And in order to get that, we're going to sub in. And let's just use -2 just for funsies. Since we have a -2 here, let's just stick -2 in for the x. So y is going to be equal to, remember, our x is going to be -2. So let's find out what our y is. Y is going to be equal to -2. And then this is going to be -2 plus 3. And that's going to be squared plus 1. So -2 plus 3. That's going to be +1. 1 times 1 is 1. 1 times -2 is -2. -2 plus 1, y is going to be equal to a -1. So y is equal to -1. So if I come over here to -2, -1, that's right there. And then I'm going to find my mirror point. It's just 1 across. So there's the other mirror point. So my vertex is -3, 1. And then one of my points over here is going to be -2, -1. My mirrored point, I just have to double this, is going to be -4, -1. And I'm going to draw my parabola to fit this. And give it just a second, and I'm going to adjust it and put it in. This should line up pretty well. I'm going to take it to this line right here. Take it to this line right here. Adjust my vertex back in place. And yeah, so that goes through both of my points pretty readily. So I think I got that one right. I did. So that is my narrow parabola. And it was narrow because it had a positive coefficient. Now, if you notice, look at this coefficient here. It's -2, right? From my vertex to my next point. Look at that. Look at that slope here. On the axis of symmetry, I have down 2 and over 1. How about that? Down 2 over 1. That's my slope, people, of my vertex or of my parabola. It's down 2 and over 1 for my initial point. How cool is that we figured that out? Now, I don't know if that stands true for all of the points on the vertex, but it works for the first one. So you can absolutely sub in to find, use that -2 to sub in and find, because it's going to give you a good number to use. So that is how we would figure out, and how we can tell just by looking at our equation, whether or not we have a narrow or a wide parabola, and then we can test it to double check our hypothesis. And that's all we have for lesson 58. I will see you in lesson 59.